robots. One is sitting on top of the other, and there goes the top one off the top. Off like a bullet into the digging area. FIT, Florida Tech, has created 2 identical robots for this competition. They started out in a stacked configuration so that they would meet the space requirements. Now, watch Florida Tech dig. See those wheels? The solid wheels? Those are diggers. They're wheels and diggers. Very unique design. Those diggers are going to dig into the regolith and dump it onto the conveyor belt. You can see them turning. These robots have to go across the obstacle field into the mining area before they can start mining. Florida Tech looks like they have both robots into the mining area. So it's possible if everything goes well, they'll be digging simultaneously. Hard to tell from this angle how much. It looks like there's some regolith on the conveyor belt on that robot on the right. The conveyor belt just inches along, creating more space to dump the regolith onto. These Florida Tech robots are black in color. There is a lot of carbon fiber composite material in these robots that keeps them very light. All these robots are scored on how much regolith they can dig, transport, and dump into the hopper, but they're also scored on their weight. A lighter weight robot will have an advantage score-wise. They're also scored on how much power they consume during their run. A robot that consumes less power will have an advantage. And these robots are also scored on how much bandwidth they use between the robot and the control center during their run. All right, both of these FIT robots appear to be not having any trouble. I can see regolith dumping off the top of the conveyor belt on the robot that's toward the center, which is on the right in this video. The robot on the right in the video, that gray spot on the corner of the conveyor belt, that's regolith that those wheels have dumped onto there. And now they're coming up to the hopper to dump this regolith onto the hopper. This is Florida Tech. 2 identical robots, both working simultaneously for Florida Tech. Now they just got to get it into that hopper. They're trying to get the regolith into that hopper. They're just not quite high. There's a little bit going in. Plenty of time though. Still 5.5 minutes left in this competition for Florida Tech and for the University of Iowa. Looks like the University of Iowa robot is still in the starting position though. a look at the University of Iowa robot. These robots are being controlled from enclosed trailers behind us. The teams can only see this one camera view, which is the lander's perspective of their robot. They also get to see the side view of the hopper. I only see 3 wheels of this robot moving right now. The robot on the left may be trying to get back to the hopper, but I do not see, hard to tell, I do not see all 4 wheels moving though. This is the camera view that the teams have of their robot. The teams do not have this camera view. Florida Tech's robot on the right in this view seems to be in a hole. We have 3.5 minutes remaining. These robots are driving and digging in regolith simulant. It is not like normal dirt, not at all. It's a little bit like talcum powder in some ways. It's very light and fluffy. It can become airborne very easily. On the other hand, it is made up of very jagged particles that interlock and connect together, and they can become very dense and hard at times. But as soon as those particles loosen up, they turn into a fluid, and it's possible to dig yourself down into a hole. So Florida Tech went with 2 identical robots. There's a weight penalty for that because you're doubling the weight of your robot. But on the other hand, if one of your robots fail, the other one can still do the job. University of Iowa and Florida Institute of Technology now have 2 minutes remaining in this, their final run of the week. The team in the control room has not given up. They're still trying to get this robot up out of this crater. There's the Florida Tech team in the control center. Troubleshooting, looking at all their camera views, looking at the data on their computer. Troubleshooting. They're learning how to be engineers. All these teams are. This competition sends these students through the entire life cycle of a robotic design project. They design the project on paper before they start building it. They build it. They test each part before they put it together. They test the entire robot after it's put together. They test the robot in environments that as closely as possible match the environment of this arena. Some of the teams practice in sand. But sand is not the same as regolith simulant. It does not react the same to your wheels and your diggers. That's why we give all the teams time during this competition, the first 2 days of this competition, are there for practice runs for these teams so they can gain experience with the regolith and make any last-minute changes that they might need to. And that's going to be it for this 10-minute run. Really good attempt for University of Iowa and for Florida Institute of Technology.